So yeah, let's just get started. Yeah, I'm John from Genesis Block. We do these Clubhouse events once a week. Typically, it's a pretty casual discussion. This is the first time we're actually recording these. And to start off, I really like to get to know kind of like the backstory of the founders that we're talking to. So yeah, Jan, Alan, it'd be great if you guys could just tell us, a bit about your background, your history. Go back as far as you'd like to, as far as kind of, what your story is and kind of what led you to cryptos and cryptography.
Sure. Hi everyone. Let me jump in. Uh, I still remember first time reading about Bitcoin on Reddit when it was at 10 cents, and of course, like a lot of people, I just thought it was an interesting idea, but didn't do anything about it. And then later on, when Bitcoin reached $200, a friend of mine was already very involved in the community, and he was trying to educate me. So he said, "Hey, buy me a latte, and I'll send you one hundredth of a Bitcoin." And so he did. But what really got but I still didn't pile into Bitcoin. What really piqued my interest was when Ethereum came onto the scene. Because throughout my career, I had worked on a number of uh, distributed systems that really stood the test of time, uh, zero downtime, always stayed on. This goal of building a software that would collaborate and be really resilient had always been an interest of mine. So when I saw Ethereum taking that concept further and enabling to join and be part of this world computer, I was just so fascinated by its potential. And so that eventually led to starting Enya with Jan a couple of years ago.
Oh, hey, good morning. This is Jan. Great to have you here. I started out as a physics professor at UC Berkeley, and I was always interested in cryptography and numbers. And something like 8 years ago, I got more and more interested in healthcare, among other things, and I moved to Stanford. And my first exposure to the compute, privacy, and social networking world was a collaboration I did with the Biden Cancer Moonshot. And the goal there was to think of new ways for people to share sensitive data. And that worked out remarkably well. We found that most individuals were very willing to share sensitive data, healthcare data in particular. That then led to an interest in privacy and secure compute and fully homomorphic encryption. Alan and I began to see a number of unmet needs in this intersection of how large numbers of people interact with computers as it relates to any kind of sensitive information, whether it's financial data or healthcare data or location data or anything else. So that's a little bit of the genesis of Enya. And I've been teaching beyond Bitcoin at Stanford in the School of Engineering now for the last 4 years. This year, I had the largest class ever. I had 186 students. So there does seem to be a considerable degree of interest and enthusiasm, certainly from our undergraduate population here.
Awesome. Thanks for sharing. So kind of that's a good segue into Enya. So what was the inspiration for Enya? And is there any kind of story behind the name?
Well, the name. Let me start with the name. Is interesting because both Jan and I are fans of Lord of the Rings, and uh, you know, one day Jan came to me and said, "Hey, what do you think about the name Enya?" I'm like, "Oh, you mean the Celtic musician, singer-songwriter? I love her. I love her music. I've been a fan of hers for many years." And he's like, "Who's Enya?" I was, I was looking up the Elfish dictionary, and Enya actually is machines in Elfish, and I thought it would be a great name for our company.
Yeah, actually means, well, the Elfish dictionary is a little bit inherently complicated. There's multiple, variants and dialects, but the one of the possible translations of Enya is algorithm or computing machine, and so.
Kind of have Alan's opinion to where I hear Enya, I'm like, oh yeah, great artist. But the kind of tie-in with Lord of the Rings, I think, really resonates with a lot of nerds like myself.
Yeah, and as for the inspiration behind the company, as Jan mentioned, we really saw a lot of potential and unmet needs at this intersection of privacy preservation and decentralization. Because when you bring a lot of people together to interact with a very decentralized software systems, um, we can't just focus on enabling technological capabilities. We've got to also think about what are the implications for the participants when they participate. Um, Whether they're operating one of the nodes or whether they're just using the service, because we are talking about a publicly available decentralized compute system, right? And it's so much easier to think about privacy issues from day one, and address them head on, as opposed to retrofitting a system afterwards, and as we've seen with the traditional internet.
Yeah, and for me personally, I'm really curious to see how the internet will play out, in the sense that several billion people now interact with the internet every single day through their phones, and uh, it's really changed how we do a lot of things, whether it's education or banking or how we navigate, how we communicate, how we connect. So all those things are changing very quickly and very significantly. And just about 10 or 20 years ago, when we interacted with a computer, we assumed that we have to divulge a lot of information to that computer to get some benefit. So, for example, we all assumed that if we want a medical diagnosis, we have to send a lot of data to the doctor, and the doctor can then compute on those data and return a result. And so we assumed that there's this inherent requirement for us to divulge a lot of information to get services. But with the new generation of secure compute approaches like fully homomorphic encryption, we can generate data, we can encrypt those data, we can have a untrusted cloud worker compute on those encrypted data, and then send us a result back that only we can decrypt. And in my book, that's a very fundamental shift in how individuals can interact with computers, because we can have those computers do stuff for us, like compute on our data, without having to worry at all about who gets to see those data. And that seems like a sort of really fundamental basic shift in how large numbers of people can interact with cloud computers or doctors or whatever else.
Yeah, thanks for that. And I think just for anyone who's listening now, or anyone who listens to this post-event, if you guys could basically describe what Enya is in a nutshell, as far as like the elevator pitch or like a simply put summary of Enya, how would you guys describe this?
Enya provides a set of APIs that developers can use to easily build the type of secure computation capabilities that Jan has just described into their applications, and these applications could be very decentralized in nature.
Or something like drop-in privacy. We want to make it very easy for developers to build tools at the edge that balance privacy with insight.